What's up, guys? Welcome. In this video, I'm going to show you and help you answer the question, how do you determine if a relation is a function? And first thing we're going to talk about is what this word right here is, relation. So let me do this. Actually, let's go to, you know what, before we do anything, let's do the definition here of relation. So here's what I want you to see. Look, relation, by definition, straight up Google definition, the way in which two or more concepts, objects, or people are connected. And the rest of it, you can read it sure, but the really first line right there is important. It's the way in which two or more concepts, objects, or people are connected. So when we're talking about relations in mathematics, in algebra or anything, it's the way in which things are connected. You're taking one particular thing and there's something that's happening that you're connecting it and mapping it to another thing. And I'm being very vague right now, but that is what a relation really is. Whenever you take one thing, like I said, and connect it to something else. But that thing that's making the connection from one to another is what we call a function. And we'll talk about that in this video too and make the distinction between what a relation and what an actual function is. So here's what you need to write into your graphic organizer for the definition. Our definition of a relation is a mapping or pairing of input values with what we're going to call output values. So that's just a generic relation. Take one thing, do something with it, which we don't even know what it is sometimes, doesn't matter. It's going to output something else. And many times you'll see this thing called a mapping diagram where you put an over here and over there or a box, it doesn't matter. And this side is going to be the inputs. And the left side is typically x's. When I say typically, it's always the x's. The inputs in any type of relation or function that we talk about is always the x value. Always. And then it's going to do something to it. It's going to map it. It's going to massage it, you know, kind of like maybe divide, add, square, square root, add pi to it. You're going to do pi, pumpkin pie. Regardless, it's going to do something to it mathematically, and it's going to map it to something else. For example, if I put 2 in over here for x, and I actually took it times 3, that was my rule, then it would output a y value, which we call 6. So 3 times 2, whatever I said, you get the idea. This thing in the middle is taking it and making it something else in output. Now here's a real life example. Who knows who Gutzen Borglum is? Yeah, I didn't either. But you know what's funny? Gutzen Borglum, I'm probably making that really not sound right. So sorry, Gutzen, or anybody that knows him, sorry. But Gutzen, here's what he did. His input was a huge mountain. He saw this huge mountain, and what he did is he massaged it. He chipped away stuff. He said, I'm going to do this. I'm going to make this. I'm going to do that. I'm going to chop this off. I'm going to make it look like this. And he massaged this entire mountain, and he made what we now know as an output of this Mount Rushmore. So he took some input, which Gutzen wasn't the input, just an example. It was the actual mountain. It started as something. He did a lot of work, no doubt a lot of work. And it outputted an unbelievable masterpiece that is now like one of the 7 awesome wonders of the world. It's unbelievably cool. Regardless, that's a simple example. Let me pull it back to some examples that we know too. Real examples. If you practice more, whether you're in a sport or you're doing something like color guard or you're in a band, you're going to be a better hitter if you're a baseball player. You're going to be a better ball player if you're basketball. You're going to be a better musician. If you practice more, input more time, your output will be a better whatever it is. If you input more homework, input more studying, your output would be that your grades are going to improve. For sure. If you input, go to work and do your job. Now you can go to work, but if you don't do your job, nothing, you're not going to get output. Well, actually, you're going to get outputted out the door. But if you go to work and do your job, then the output would be getting paid. So there's some real examples in terms of, inputting something to outputting it. But let me kind of pull this full circle, because there's 4 ways that you're going to see how relations are given to you. One is order pairs. The second one you see is coordinate plane. Third one is table, and the fourth one is a mapping diagram, which I just described it to you. So let me cut to something so I can show you exactly what that's going to look like. So here's an example. You can see it right there. Move this over. Beep. So beautiful. So you see right here in this picture, you see a relation example. What you actually see first is order pairs. You see these things here in green, all these guys, they're just an order pair. In fact, it actually would look like, it would look like this. It would be a set, comma there, comma there, comma there. So it can be given you one way as a set of ordered pairs. Another way a relation would be given to you as, again, x input value, y output value, x input value, y output value, x input, y output. You could do it as a coordinate plane, where this, again, remember, is your x-axis, so your input right here would be -3, your output would be +5. So this point here, -3, 5, would go right there. This point, input is a, well, actually, yeah, that's right. That input is 1, output is 2. X is 1, Y is 2. This one, input is 2, output is 7. So that point right there would be 2, 7. So there's another way that you're going to see a relation represented. You also see it in a table. We've seen this before in XY table. -3 is being mapped to 5, 2 is being mapped to 7, 1 is being mapped to 2. They're connected, they're related that way. Down here, or over there in this one, mapping diagram, this is where you would say, hey, -3 is mapped over here to what this tells me up here of 5. And 2 would go to 7, and 1 would go to 2. So there's a couple different ways that you're going to see relations related, that's the wrong word, relations represented. There's a word. Okay? So let's keep on going. Let me get back to the PowerPoint. So let me move this over so you get the whole thing. This is great. Okay. So here's the thing, though, in your graphic organizer that is an extremely important word. And no, domain is not something that you just ordered last night at the Chinese buffet. Nice try. You can go in and say, yo, I want some domain. They're going to say, you're crazy. Get out. Domain is this in terms of algebra or any type of mathematical thing. The domain is always the set. Boy, there's a key word. It's the set of all input values. That is your domain. It is the x values. The domain is the x values, the input thing. This thing in the middle is going to be our rule, which you're going to see shortly is going to be our function or whatever. And then over here, R stands for a thing called range. And range is the set of output values. So domain's input, range is output. So if I practice more, that's my domain. I'm going to output my range, being a better player, better hitter, better musician, whatever. So there is domain and range. Now in the actual example, which I'd probably throw into your notes too, here's a specific one. You got 4, 2, -1, 0. Those are your x values, your x whatever they are, your x inputs. So these are your x's. Whatever's happening here is being mapped, so 4 is being mapped to 6, your y values. 2 is going to 4, -1 is going to 1, 0 is going to 2. Very simple. That is exactly nothing more than what domain range is. This side over here, this side over here is your domain, all of this stuff. That's getting ugly. This side over here is all your range. Woo! Okay? So what about an example like this, where you have a coordinate plane that's given to you? Well, what would your domain be? Great question. Is it a relation? Sure. I mean, we're just taking x's and y's and comparing them together, no problem. Or pairing them together. So the domain would be all of your x values, all of your x's that's on the graph. Well, let's see. There's an x value, so it's 1, 2, 3, 4. So one of my particular domains would be -4. Another one would be -2, because that's my x coordinate there. So -2 is another one. Another one would be 0. There's another x coordinate for this guy. And the other domain for this one would be a +3. Beautiful. So there's my domain for this particular graph, because again, it's all of the x coordinates. The range is all the y coordinates. So where's that? Well, here's one of them. It's at 0. So one of my range, one of my y's is 0. One of my other ones is +2. One of my other ones is 1, 2, 3, 4, 5. And another y value, another range would be 1, 2, and 3. So there is my domain, and there is my range. Domain again is all my x's. Range again is all my y's. All these guys. Right there's one, right there's one, right there's one, right there's one. And of course I'm talking about this. That ordered pair right there would be 1, 2, 3, 4. It'd be -4, comma, 2. And now notice, this is an x, one of my input values, check. And this right here is one of my y's, one of my output values, range, check. That's how it works. Over here on the right one, what is my range and domain? Domain and range. Well, from here, the whole way down to here, whoops, the whole way down to there, all of those x's are my domain. So, my domain would then be less than 1, 2, 3, 4, 5, or equal to 5, but it's got to be greater than or equal to -3. Ooh, a compound inequality. Nice. So it's got to be between. Notice I'm shading between these two things. There's a little hint. And inequality. So my domain is somewhere between those two x values. Well, then my range is going to be my y's. Well, that means right here is a y value. The whole way up to here is my other y value. So that range means it's got to be somewhere less than or equal to, and I say equal to because it's a closed dot, 1, 2, 3, 4, 5, 6, 7. So it's got to be less than 7, and the whole way down to 0. So it's got to be somewhere between 0 and 7. So there's your domain, and there's your range. Alright, so there you go. So that's relation, and then leading into what domain, input value, and range, output value is. And now we're going to get into the FUN, the fun part. I'm going to stop this video so it's not so long and do another video, quick video on what functions are, so you get a chance to realize how fun functions really are. We'll see you in that video.